were chatting about topics that would be of interest to the group. And one of them was, well, how did we all get here? How was the world created? And our bias is definitely as a Christian youth group. So how does it all fit in to the biblical historicity? So in terms of evolution or creationism, how does historicity, how does it all fit in to our belief system? And at that time, Megan had mentioned a speaker that came to her class, and it was Dr. Kirk Durston, and she was pretty impressed, not only by his knowledge, but probably more so really by his tact and the respect in which he presented the topic. So I want to make sure that whatever your belief system, as you sit here, I want to make sure you feel very welcome. I want this to be a very safe place for that, and I believe that's Dr. Durston's intent as well. As I look in the Bible, and you look at Paul, he was one of the founders of the New Testament church, and it says that he went into the synagogues and he reasoned with the with the Jews, and he went out and he reasoned with the Greeks. And I'm a firm believer in reasoning, and we're really here to do that tonight. Obviously, faith is a cornerstone of a belief system, but the Bible definitely doesn't discount reasoning, and that's why I'm very excited about tonight. One of the key verses of the Bible that we talk about says, "Always be prepared to give an answer to everyone who asks you to give the reason for the hope that you have, but do this with gentleness and respect." And I think the latter is something that is often missed, certainly within Christian circles and outside of that. So whatever's presented here tonight, I believe, will be done with gentleness and respect. So feel free to ask questions afterwards. I think Dr. Durston is looking at having a presentation in about 45 minutes. We'll have a Q&A session after that. And after that, there's some refreshments downstairs, because we don't want to disappoint people that usually come to our house on Saturday, because they count on sweets and things like that. Sometimes I wonder whether that's the primary reason they come to our house, but if that's the case, I'm okay with that. And we've got some drinks downstairs as well, so please stick around for that afterwards. I'm going to ask Megan to come forward and introduce Dr. Durston.
Hey guys, welcome. So we're really privileged to have Dr. Kirk Durston coming and speaking with us, or presenting tonight. And over the summer, I did have a chance to actually listen to two of his presentations, once at camp, once at school. Both times, I was equally impressed and really, really appreciated his discussions, as well as his respect above all things for people who have different ideas as well. And Mr. Durston is the National Director of the New Scholar Society, has his PhD in biophysics, Master's in philosophy, Bachelor's of Science in mechanical engineering, and Bachelor's of Science in physics, I believe. Is that right? Yeah. And if I remember correctly, you've been in university for 14 years?
At least, yeah.
Yeah. Yeah, something insane like that. So, Dr. Kirk Durston.
During the Q&A, you just spoke to Kirk. Second thing is, there was a time in when Christianity was the environment within which knowledge was advancing and science was included in that. That's kind of deviated away from that in the past century or so. But what we're going to see here tonight is an attempt to get us thinking once again and take leadership in the area of a particular area that I'm looking at here. This is not going to be an easy lecture to understand. It's going to stretch your minds, but I think that's a good thing. And the other thing that will happen is that some of you, it will be well over your head, but I think you'll still get the general drift of what I'm saying, and there will be a Q&A at the end. So let me just begin here by giving you an overview of what we're going to cover, and then I'll just move right along to the more interesting part here. Let's start off with some definitions, first of all, so that when I'm using certain words, you know what I'm talking about. And the first one would be intelligence. And I've just taken this off the Wikipedia website, just for the sake of having a definition that everybody can look at, and probably gets adjusted over time. But It's basically the capacity to reason, to plan, to solve problems, to think outside, to comprehend ideas, to use language, and to learn. Note something here, and that is the role of information in underlying these aspects. Not just information in the sense of a stream of gibberish, but information that's actually useful, or functional information. We're going to come back to that term in a bit. But it's information that's useful to plan, to solve problems, and so forth. I also want to define what I mean by the IF hypothesis, and it is as follows. The IF, I stands for information, the subscript F just represents functional information. And it's basically the hypothesis is that a unique property of intelligence is the ability to produce functional information. It's the fingerprint of, it's one of the fingerprints of intelligence. If you see a brilliant essay or brilliant poem or brilliant piece of music, you can actually quantify the information in that poem or music. You can actually quantify that. And the ability to produce that, if it turns out to be statistically significant, has the fingerprint of intelligence on it. I don't know, it's almost obvious, I think. Fingerprint of intelligence constitutes positive evidence for an intelligent source, for example, computer code. And on the right, you just see a piece of software, some code for a piece of software. And that's what I mean by, that's an example of functional information. It's information that's useful for something. And there's three major categories. There's some papers that have been published on this area. Three major categories of functional information. One would be human languages. Second major area is the area of genetic information. And the third major area is computer code or computer software. Those are the three major areas. Those are the only three areas where we find significant levels of functional information we actually measure. And it's interesting that two of those areas we know for a fact are produced by intelligence, computer code, and human languages. The question is the genetic information, functional information in our genes, is that produced by an intelligent agent? So for biology, I want to define what intelligent design means, what I'm talking about when I use those terms. Intelligent design is the hypothesis that intelligence was required for the origin and the diversity of biological life. The hypothesis is actually testable through a scientific method of design detection, which we apply to biological life. And I'll clarify that as we move along. To your right, you see an example of a molecular machine. It is a small device that's used to ratchet the DNA into the protein capsule of viruses. The DNA is very tightly packed in these protein capsules, and the question is, how did it get so tightly packed in there? And eventually it was discovered that there's actually a little machine that ratchets the DNA in there one little turn at a time. So that's all I'll say for right now with regard to definitions. Second major aspect of this presentation has to do with the distinction between philosophy and science. A very important distinction to be made, because one of the objections that I've run into on an ongoing basis when I'm going through some of this stuff is they'll say, well, that's religion, it's not science. So let's clarify what the difference between those two are. With the area of design detection, what the job of science is to come up with an empirical method to test for intelligent design. That's the design detection aspect of science. It has to come up with an empirical method. That's strictly scientific there. And then it applies that to an object or a sequence being examined. That's part of the job of science. Then it'll either come out with a high probability that intelligence was required to produce that object or that sequence, or not a high probability of intelligent design was required. That's still the job of science. If it turns out that it's highly probable that intelligence was required to produce that effect or that sequence or that piece of software, then the next step is reverse engineering or design derivation. And what that does is it looks at the question of how does this thing work, or how was it made, how was it produced. If it turns out that there was not a high probability that intelligence was required, then the job of science is to give a ground-up presentation ground-up explanation, beginning with first principles and then work your way up there to explain the effect. That entire section there that we've looked at thus far is the job of science. In either case, when it comes to biological life at least, in either case there are going to be philosophical and theological implications. That's the job of the philosophers and the theologians. And what I see happening often is that scientists will see the philosophical implications and conflate that with the other stuff on the left and fail to do their job as a scientist. That is, to come up with a method of design detection that you can apply to all sorts of different things, which we're going to see shortly. And then that answers the question and leave the philosophical implications up to the philosophers and the theologians. Part 3. 3 categories. This looks at 3 categories where intelligent design is already firmly entrenched in science. The first is design application. That is where we use our human intelligence, for example, and apply that, given our knowledge of the first principles of the laws of nature and so forth, apply that to build things, to design things. Here's one example. The binary code strategy was used to design recently a simple novel protein. This paper is the reference down the lower left-hand corner, and I just counted the number of times the word design was used. 29 times in the text, title, captions, and abstract. That artificial protein is an example of intelligent design in action. And we see that throughout science. Whenever you have intelligence being applied to a scientific problem, you have an example of design application. Genetic algorithms, for example. Another example of intelligent design in action, because in genetic algorithms, you require a fitness function that's carefully thought through and designed so that the search will progress and converge on a possible answer. In general, designing and building life in the lab is an example of intelligent design in action because it produces a model for the origin of life. When we produce a model, that's intelligent design in action. You have intelligent scientists working in a lab attempting to build something on the basis of knowledge and intelligence. So that's an example of design application in science. Now let's look at a second area where intelligent design is firmly entrenched in science, and that is in the area of design derivation. That is where you begin with the complex system and work your way back, taking it apart, examining it, work your way all the way back to the first principles. In 1976, Sergeant Bolenko defected from the USSR with a MiG-25. The Western world had never got to examine a MiG-25 interceptor jet before. He flew it into Japan, and at that point, the scientists in the Western world, the engineers, carefully dismantled that MiG-25 jet to see how it was built and to understand the technology and the design principles that the Soviets had used in building that aircraft. That's an example of design derivation. Genetics. That's probably the single largest, most ambitious project that humans have ever embarked upon in the area of reverse engineering or design derivation. We have the finished product, and now we're trying to figure out how this all works, how it's all produced. Another molecular machine at work off to the right. Finally, the third major area where intelligent design is involved in modern science is in the area of design detection. This is the analysis of artifacts, signals, and situations to determine if intelligence was required to produce the effect or was involved.